Hello and welcome back everyone. Now we are going to learn and start a new section whose name is Computer Organization and Architecture. Well, this topic is kind of organization basis, and if you ponder about its wordings itself, you may ask the question that how it's working and what is the meaning of this section. So let's get introduced with this section first. Well, in the computers, we need the organization. Well, you may ask that what kind of the organization we need. As in the real world or in the corporate world and in all the worlds, in our world actually, what we need to do if you decide to do one work, you have some checklist that you have to do. And when all the ticks are there, the work is finished. But it requires to go through a process, and that process takes some time and planning. Then together with working with our teams, that becomes organization. When a team works with a definite planning in a definite direction in a limited time and process something, gives some output, that is called organization. So how the computer organize these all the things, that is what we are going to learn in computer organization. And what the term architecture mean here? Well, architecture is the design. Architecture is the design, or you can say it's a logic that plans and brings us the blueprint. With that blueprint, we actually make our things or action happen. So if you want your machine to do something, you want to have it working on a definite architecture. Well, we are going to learn that in great detail. Just for now, for the sake of the curiosity, there are RISC and CISC. So these are the two architectures that we are going to study, and we'll study each and every topic in a great detail. So this is what it means to have computer organization and architecture. With all that said, this is all about the introduction, and there is a lot of the fun things that we are going to learn on the way. So let's make it happen. So first thing first, as in the broad topic, we are going to cover machine instruction, machines instructions, how the machine take the instructions from the instructor and actually perform its action. And also we will study about its addressing modes, so how the address actually works, because you should know the address, like you should know the K-band, where the manager is sitting, the location where your receptionist is there, the place where the engineer works, every kind of the thing. So we have a definite place for a definite action, and with a definite memory, process, output, input, and all that kind of the things. So we need a kind of address so that we can reach from one place to another and finish up our final product, final good. Well, that's what we want. So what we actually do here, let's see that what is coming in this section. In this section, we are going to study about the machine instruction, in which we will study about what are the registers, and then we are going to study about the instructions, Well, we have already discussed it, but we will discuss that what kind of the instruction I am talking about. We will execute few things, we will learn few keywords. Well, in short, you can call them syntax or format that will going to describe that which action has to be performed. Then we will learn about the subroutines, and after the subroutines, we will going to learn about the instruction cycle. Well, that's the part of the subroutine itself, so I will call it instruction format. We will learn about the instruction format. So these are the upcoming ones in our machine instruction and addressing mode. So let's study one after another and let's begin with this. So what we need to learn first here, the first thing first, that what is addressing mode. So can you guess, my dear friend, what the addressing mode can actually mean? That's an interesting concept, right? So addressing mode is the location in the memory, is the location in the memory. So addressing mode is the location in the memory that is going to take a particular kind of the instruction and give us a particular information that is being stored in that point, or on that point, you can say. So this is about the addressing mode. With all that in the brief set, we will come back to this one again, but for now we are going to proceed on our first topic, which is going to be register transfer language. Register transfer language. But as the name suggests, we have a register that transfers a particular language. So first of all, let's understand that what is the meaning of the register itself. So the register actually means the register actually means you have a set of the instructions written in the memory or saved in the memory. When you require a, when you type in a particular address or you command for something, it will go look, it's this one, this one, this one, this one, hey, it's this one. So it will going to pick it up and give that to you. So register is the kind of the record center. It keeps all the records, all the data that we store, and then whenever we require we can go to the register and we can look for the data. Like in the real life, manual work were done few decades ago, so that was the procedure of doing so. So this is the register. Now, what is the meaning of the register transfer language? Let me introduce you with that. The basic memory unit of a digital system is register. Well, let's write it also so that you can see the things quite clearly. The basic memory unit of a digital system is called register. But as I said, I am just written the same thing, that the basic memory unit, the information or the data that you store digitally, because we are talking about the digital electronics, so the data is stored digitally, is called register. So in just one word, this was the bookish language that I just wrote. This is the kind of definition that we use in our books and all for our reference. But in one word, what it actually means: record keeper. That's it. Either you are keeping the records on your notebook or you are keeping it digital or digital file. It's just a record keeping. That's it. That's all what it means. Now, register are used to hold the data as we discussed. Maybe this is the third time we are discussing the same thing, but don't worry, things come up in a different way and transfer the data required. So, this is what digitally added and transfer the data required. Like I don't want to store something that I cannot even able to see that again. So I have to store that in such a way that is stored. So we want to retrieve that data again whenever we require. Like for example, you are putting the 2 plus 2 and equal to what? You asked your machine or a simple calculator, let's say. So what's going to happen? This 2 is going to store for a moment, then it knows that it has to process the addition, and then these 2 is going to add, and when these both two process, we are going to get our result as 4. Now this is our answer. But even for this slightest and simplest operation, we want a basic register to store these two numbers in that, so that the operation, which is addition in this case, can be applied can be applied and then we are going to get our definite answer, and when we are going to get our definite answer, we will going to get our result, which is 4. So this is the way our register works. I hope it becomes crystal clear to you that what is the meaning of the register. So we have crossed one of the level, that is the register, and the transfer also. As I said, that it transfers through the operation, that whichever operation is being followed, it transfer according to that. And now it's about the language. But it processes in the assembly language mostly. But if you are programming in any way, it we use the compilers. In simple words, if you're using the Python language, C programming, C++, Java, JavaScript, or any of the language, what actually happens is a compiler is there and that compiles the program, and we get a definite kind of the result, and that result is going to give us the information. That's it. That's all it. Sometimes it performs, sometimes it keeps store, and everything that you can imagine. Well, let me introduce you with the few operations that I would like to present. So, operations, operations um, are described below, but I don't want to write that up. So I'm writing it as what to write? Register transfer information, RTI. That's it. We are going to study that one. So let's see what I meant with this. With the first point, I am coming up with you information transfer from register 1 to register 2. So this is something that happens. Second thing that we can understand is if the value of the P, if P, let's say P is something that is initialized with 1, P equal to 1, then data transferred from R1 to R2, where P is control signal. Well, where P is our control signal. So we are having a control signal here, like you have remembered it, right? Yes, exactly, like these ones that we have studied in the multiplexer, demultiplexer, and the previous section. So we can write it as P R2 gets the data from R1. That's it. That's all it. That's what it means. But It does not seem like I just wrote the lines. So let's have something more visual. So for the visual part, let's make the diagram so that we can understand things more clearly and enhance our experience of learning to the next level. So let's name our things. So this is control circuit. Control circuit. And the next one, this is what we mean with the P. This is the P. And now the P is going to load up in R2 in the definite time. So we have a clock here also. Now n bit uh, data gets transferred. You can take any bit. I am taking n bit so that everything is working on the pretty much same thing. So R1. That's what actually happens throughout that point. So this is what actually happens. Control signal loads it and it takes the data from R1 and now the data is on R2 or second register, you can say, for the simplest of the thing. So this is what happened here, and point 2 is just the extension of the point 1 in the reversed way. Well, that's it. That's all what I meant with. In this, I am representing that R1 is giving the data to R2, and in second one, I am presenting that R2 is receiving the data from R1. So this is pretty much the same. The only difference that is making is through the control circuit, which is P, which is actually controlling that how much data, which data we actually wanted. Like imagine you have so many images stored in your phone, but you want your device, when you click on a particular image, you want only this device to show up, not all the devices. So this is stored in a bigger register. Let's name it R1, and on the R2 on your screen there is a smaller register that shows you this particular image, and this particular image that we look at is loaded in register 2. But how in the world we know that we require only this one and not every of that? So we know that because of the control, we have the control. I clicked on it, right? So when you control, so technically and digitally, there is a control circuit that controls the entire information and brings the particular file in the register 2. It loads up, and then we are able to see the things on our screen, that particular image on our screen, not all the photos at the same time. Well, you can do so sometimes, but we are talking about just one at a time for now. So this is the point that I wanted to learn you. Okay, I wanted you to learn. That's what I meant with. So let's study the third point. Well, the third point is, let's say if t is equals to 1 and the data is is transferred from R1 to R2. Well, till this point it seems pretty much the same statement, but just look at this one. And R3 to R4. So now it's making a little bit of the difference, because if t equal to 1 means this time, t is the time. So on the time, on a particular time, I want R2 to receive the information that is stored in the R1, and on the same time or maybe in a different time, that depends on our system and what to say, it depends that you are using a Mac, Windows, Linux, Android. You understood that, okay? So it receives R4, R4 is receiving data from R3, register third. So this is what happens at C is equals to 1. Now let's get into few more deeper commands that we can have here. So the fourth thing that we have is information transfer from from bus to R1. Well, if you do not know what is the bus, I'm going to explain that, and if you know that, you just got it. So this is the bus. Well, if you have ever pondered about the device or just messed up like me with your device, you surely have seen that in your pen drive or USB drive, betterly said, USB drive, you surely have seen these kind of the lines that is coming out also. So these are the data lines, and these transfer information and sometimes also power. So this transfer power and data. So what it actually means, how it's happening, and what it actually do. Well, the most important thing it do is to transfer the information. So these are the lines or routes. That's why we call them buses. Like right now, I have 1, 2, 3, 4, 5. I mentioned the 5 bus here and 1, 2, 3, 4 buses here. So these are called the buses. You can call them a route. That's how the data transfers. Well, I call them highway of the information. Okay, now let's get to the fifth point, which is data transferred from address. Let's name it weirdly ADDR to register A. So we have this one. So what it actually do? Well, we read A is actually reading from ADDR, or just simply address. Well, that's the short form for the address, but I named it like this. You can name it A, B, C, or whatever you like to. Does not matter. I just mentioned the address, so address can be anything. Okay, so from this address, the data is read. So data is transferred. Like let's say you have a file or folder in which you have so many of the different things, 1, 2, 3, 4, 5, and so on. Okay, now you want the address 2 to be read. So what you actually do, you go to address 2, you bring out, and whichever information address 2 is storing, let's say address 2 is storing the information A. I'm writing it with the red color. So A will be read. A will actually A will A. So let me remove the A so that we will not get confused. Let me write that in. Let's say there is a picture. Okay. Now there is a picture. So this picture is being read. I just removed the A because we will get the double A, so the confusion thing will arise. That's why, nothing else. So whatever the information stored in the number 2 or the address 2, they're going to get that, and the data transferred get loads into our main memory, and then we study that thing. That's the whole concept. So this is about the reading. Okay, let's uh, have the last one, that is addition. So what happened in the case of the addition? Well, if you look closely, you will get marvelous one, because it's just simply add R1 plus R2. That's it. That's all what it earns. But that is transferred to R1. Well, we can design it in a different way, but this is one of the way of designing. If you're familiar with the programming languages, we usually write it like this: A plus B. So what it means actually, the A is a number, and then let's say B is a number. Then we stored the 5, the result is 5, that is again stored in the number A. Means the previous value 2 gets updated or deleted, and it get updated with the number 5. So 2 will be removed, 5 will be updated in the A. So this is one of the way of reducing the garbage memory which will not be useful. Like the number 2 is not useful for us anymore. What we wanted is the number 5 as the result. So we focus on the result and we get result oriented, and surely the B will also not be used after that. So B will get free for the another operation. That's how the programming language works, and that's how we need to design our circuit too. So you can relate that to every single point. That's how it happened. Well, let's take all the examples to understand this. Like, let's say we have R1 plus R2 that gets stored in the R1, and R1 again we have the operation this time on the subtraction. The same thing happened. Now for the complement, let's say this is the complement, this was the subtraction, and this is the addition that we just discussed. And the complement, what happened actually, R1 gets the R1 bar, means 0 becomes 1, 1 becomes 0, that thing. We have increment. In the increment, what we do? Well, we increment the value like R1 plus 1. Well, in the C programming and in the most of the programming languages, increment is written as plus plus. That's how it's done. And now we also have the decrement of the value, which is R1 minus 1. So this is the decrement. Well, if you are familiar with any of the programming language basics, you will surely able to relate it. And if not, just understand that this is how the programming language is going to work. On this basis, our programming languages are made and it works. So this is how the things are happening. So I hope you have understood the concept. Let me re-explain that to you so that we can clarify everything once more. So let's revise. Let's come to the revision mode for the address one that we have just studied. So let's study its core concept. Study core. I call it study core. So in the study core, we are going to see that we have two spaces, like these two spaces. In one space, we are having the number which is stored, let's say 8, and in this space, we have stored number 1. Now we need to apply some operation, let's say addition, or let's say subtraction this time. Now, what is going to happen? The two memory bits are used here. Two memory bits are used here. Now on the final operation, what is going to be the result? The result is going to be the 9. No, the result is going to be 7. That's it. So the result is going to be the 7, the number 7. Now, do we need these things? No, obviously not. So is it going to be wasted and we need the third bit? So yes, for a moment, but this third bit actually updates this bit, and the two bits which were storing 8 and 1 gets freed. So this gets free for another operation. This gets empty, so that we can perform new operation and we have our answer 7. That's how we use our space very efficiently. That's how the things happen. Okay, in the next one we will study about the basic assembly language programming. Well, that's very exciting one, because the assembly language is the mediator between the low language and the high language. So this is gonna be exciting one. We will learn few of its command, and then we will see that what gives us what. So that's it for this one. I hope you have enjoyed this small teeny tiny introduction along with the machine instruction and addressing mode, the topic we are studying. So stick with me, take care, and see you on the next one.